Hello and welcome APCSP students. My name is Alex and today at Open Source Education we'll be doing a full APCSP review, all units in an hour with detailed explanations and practice questions. So how is the exam structured? The AP exam has two parts. It's going to have a multiple choice section and a create performance task section. Hopefully you submitted your portfolio, which was due 12 days ago. If you did not, my condolences. Multiple choice section is going to have 70 questions and it's going to last 120 minutes. Plenty of time to finish the questions and nap. And the great performance task is going to have just 2 questions and it's going to be a whole hour to complete those 2. Today we're focusing on the concepts that will be tested in the multiple choice section. However, some of these also apply to the pre-response. Let's begin with our first main idea, creative development. The first topic is collaboration. Here are some definitions you have to know. Computing innovation is something that has a program as a core part of its function. And these innovations can be physical, such as self-driving cars or smartwatches, non-physical, like ChatGPT that you use to complete your homework, hopefully not, and conceptual, like artificial intelligence in general. And a program is simply a set of instructions that a computer has to complete. Some differences you have to know. Hopefully you injected them into your brain. Let's continue. Why do we collaborate? Because it creates diverse perspectives and less bias. And also it allows us to get some user feedback. So we have many opinions in one single program and not just some guy who thinks he's the best and wants to have his opinion in his program. How do we collaborate? We collaborate with online tools and something called pair programming. That's also a definition you have to know. That's when 2 people sit at one computer and one writes the code while the other suggests ideas, as shown on the picture. Some collaborative skills that you will have to know and will be somewhat tested on them. Communication, consensus building, like making general agreements between each other, conflict resolution, and negotiation. So that's something you have to know. Next is topic 1.2, program function and purpose. Why do we need innovations? Well, because innovations solve problems. Like ChatGPT solves problems and self-driving cars also solve problems. And knowing the purpose helps with developing the innovation. If you don't know what you're making, then why are you making it? Program structure. So a program or software is a set of instructions that performs a specific task when it's ran by a computer. A code segment is a collection of program statements. So it have multiple lines of code, for instance. Also, you have to know inputs, something that goes into the program, and outputs, something that goes out of the program. Input can be, for example, pressing a key. Output can be, for example, a sound that the program makes. Program inputs. Inputs is any data sent to a computer. It can be tactile, audio, visual, or textual. It can be from users directly or from other programs. An event is a notification to the program that an input has happened. And event-driven programming is a program that executes something because of an event, rather than sequential order of operations. For example, clicking a key to perform some code segment. Program outputs. So outputs are data sent from a program, and they can also be tactile, audio, visual, or textual. Program design and development. So types of development processes. There's iterative, where you do feedback, then coding, then ask for feedback again, and then code again. Or incremental. Incremental is you have a big task you have to do. Instead, you break down that task into smaller chunks and do those smaller chunks. Some core parts of development include investigating and reflecting, designing, obviously like designing the interface of the app, prototyping, and testing. Make sure you're familiar with what they are. Program design. Let's talk about investigation. It's when you analyze the audience, purpose, or specifications of a program. It can be performed through various ways, such as surveys, user testing, interviews, and direct observations. Program requirements are guidelines of how a program must function, and specifications define those requirements. Now let's talk about design steps specifically. This includes brainstorming, planning and storyboarding, organizing the program, creating interfaces, and developing a testing strategy. It might seem like there's a lot of stuff you have to learn, but don't be intimidated by this. A lot of this comes down to your common sense, and most of these questions aren't that tricky. Next, program documentation. Documentation, if you don't know, it's a description of how a program segment functions and how it was developed. For example, comments can be documentation. Or here on the right, we have Python documentation. And this helps us understand programs. Helps the person, or in some cases, AI like Cloud Code, understand the segments. And it's important to acknowledge and credit the authors in the documentation when using someone else's code. Now let's talk about errors. There are several types you have to know. Logic error is a mistake in the algorithm. A syntax error is a program written with bad grammar. So for instance, you write parent instead of print. A runtime error is an error that occurs during execution of a program. Overflow is an error with rounding when a number provided is too big. And roundoff error that is an error where a number can't be exactly represented in computer memory. How do you actually find these errors? We do test cases, we hand trace code, we visualize our code, we use debuggers, and we add print statements to see outputs throughout various levels of the program. So here is an example of a rounding error in Python. When we try to run this code segment, so 0.1 plus 0.1 plus 0.1, that should be 3, right? That should be 3, but let's run it. And we get false. That's because Python actually rounds these answers. So we don't get 0.3, we get 0.3, bunch of zeros, and then a 4 at the end. So that's called a round-off error. Hopefully you haven't just been sitting here with one AirPod staring at the screen and zoning out. Let's test it out. Question 1. Read the question. I'll tell you the answer. Five, 4, 3, 2, 1. The answer is D. Question 2. Five, 4, 3, 2, 1. The correct answer is C, because they aren't really collaborating in this case. Question 3. Five, 4, 3, 2, 1. Collaboration does not eliminate the need for software testing. You still have to test your apps. It just adds more opinions. Question 4. 5, 4, 3, 2, 1. The correct answer is C, because we still have to resolve differences of opinion. Question 5. The correct answer is A. Let's move on to big idea 2. This big idea is about data. Right, types of data. There's digital data, analog, and that's it. Digital data has discrete values, either as ones or zeros. So these are called bits. For instance, MP3 files or text files. And these are the values that computers represent. Analog data is a continuous spectrum of data, so real-life data, such as an analog clock or sound waves. Analog data can be converted to digital data do something called sampling. And sampling is measuring analog data at regular intervals, called samples. Now let's actually talk about bits. Let's talk about a bit about bits. It's the smallest unit of data in computing. It can be either 0 or 1. Also, another unit you have to know is a byte that has 8 bits. So these bits can be used to represent different values. For example, this sequence of zeros and ones can be used to represent the number 65, the letter A in ASCII characters, or a medium dark gray pixel in a grayscale system out of 255. You don't have to know this stuff, but if you do, you're a smart person. Here are some equivalents. Might be useful to know. I don't think you'll impress the readers much, but good to know for the future once the RAM prices drop. Abstraction. Abstraction is a process by which you simplify something by hiding its details. And bits are abstractions of real data. If you're thinking, what the hell is an abstraction? I don't understand. Think of it like this. You're using your phone every day. Are you bothered by how it was made, how the chips were created, how all the processes on your phone are done, what calculation is going on right now? No, you're not. Or maybe you are, but you're an outlier in the case. That's called an abstraction. Bits are used to store data, and some languages have fixed amount of bits, which can cause overflow errors, which we learned about previously. And some operations have to be approximated because of that. There are also other languages that automatically use abstraction to store really big numbers. Now let's learn how to convert decimal to binary and the other way around. So here are the steps of how to divide a decimal number to a binary. Convert a decimal number to a binary. First, you have to divide the number by 2. Then check if the remainder is 1 or 0. Write the remainder in the end and repeat until you get to 0. Let's convert the decimal number 23 into binary. First, you have to divide it by 2. If we divide it by 2, we get 11 and the remainder of 1. So therefore, we write 1 at the end. And keep in mind we have 11 right now. Now we divide 11 by 2. We get 5, remainder of 1. So write 1 again. And then divide 5 by 2. We get 2, remainder of 1. So you put 1. Then we have 2. 2 divided by 2 is 0. It's 1 with the remainder of 0. And then we have 1. 1 divided by 2, it has a remainder of 1. It's 0 with the remainder of 1. And we get this number. Now it's a good practice to know how to convert the other way around. To convert the other way around, we think of it this way. This corresponds to 1, 2, 4, 8, and this corresponds to 16. Basically 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. So whenever you have a 0, you just don't count that number in the calculation. So it'll be 1 plus 2 plus 4 plus 16, which is 23. So that's how you convert from decimal to binary and other way around. I think that's the most straightforward way to do it. I hope you're liking the video thus far. If you are, then I think you might also enjoy our summer courses. At Open Source Education, we host summer courses in programming, but also AP classes. So if you're entering a new rigorous AP class and want to prepare for it, or just want to dive deeper into programming, then these summer courses are right for you. Check us out at osc.codes. And we hope to see you this summer. Next, you have to know about compression. That's topic 2.2. Compression is when you reduce the amount of bits you need to store a certain piece of information. So that means you can store the same amount of information in fewer bits. For example, you can store the number 67 in 5 megabytes instead of 10 if you have it as an image. But fewer bits doesn't always equal less information. You can contain the exact same amount of information, just use fewer bits. That's what's called as lossless compression. It takes less bits and the data can be completely restored. So same exact 4K image of the story meme. On the other hand, lossy compression has a more significant storage reduction, but the data can't be completely restored. How do we extract information from data? We use facts and patterns. We also have to use multiple sources to have the best results, and sometimes you have to do additional research to find full correlation in the data. Next, metadata. Metadata is data about data. For example, date of creation, file size, location of where an image was taken, camera size, and whether the image is AI'd. For example, Apple Intelligence adds a piece of metadata. And this does not impact the actual data. And this allows the data to be completely restored. Here's a demonstration of the metadata for a photo over there. Now, how do we extract information from data? There are some challenges. For example, needing to clean data, we have incomplete data, invalid data, needing to combine different data sources, or some other issues, like spelling. Sometimes there's also abbreviations and capitalizations. For example, if some people write like this, I don't know which goofball would write Pichton, but okay, that's some data cleaning. Need to hire a data cleaner to solve this. How do we clean data? We just take it and clean it. And we do it so by making it uniform. Also, there's something called bias. So the more data you have, the less biased it will be, because simply you have more information to go off of and find correlations. And also depends where you got your data from. If you got your data from some random Roblox server, probably not going to be as accurate as the data from a governmental organization or a non-profit of some sort, like us. Topic 2.4 is about using programs with data. How do we work with data? We do it in our daily lives, for example, with search tools, which make it easier to look for information. With filtering tools, which narrow down data sets for specific categories, and also with spreadsheets, which organize the data. For example, Excel. We can do these operations with data. I think you guys know how to read, and that's a good test too. That's a good thing to practice for the test. So take a brief 5 seconds to read this list out. Alright, practice. Here's some questions. Read for a bit and answer. By the way, these questions are AP style. So something similar is going to appear on your exam and hopefully not going to jump scare you. The correct answer is C. Five, 4, 6, 7, 2, 1. Answer is D. Third question. 5, 4, 3, 2, 1. Answer is B. Fourth question. Feel free to pause right now. Fourth question is C. Fifth question. Five, 4, 3, 2, 1. The correct answer is D. For this might seem a little difficult for some people, so I'm going to explain. Basically, when you have 3 bits, so when you have 1, 2, 3, a maximum number is going to have all ones, and this number is going to be as what we learned in our binary conversions. It's going to be 4 plus 2 plus 1, which is 7. So 8 doesn't fit there. 8 is too big for these slots. So therefore 8 is the correct answer. By the way, if you're liking my calligraphy, click the subscribe button and like the video to see more of such explanations and course guides. Question 6. I gotta do some conversion for this question. 5, 4, 3, 2, 1. D. Question 7. 5, 4, 3, 2, 1. Answer is A. Question 8. It's a long number, so take your time, write diligently on the paper. And 3, 2, 1. Answer is C. Question 9. 5, 4, 3, 2, 1. C. Alright, as you can see, we are moving on to the next big idea, which is algorithms and programming. Variables store values. It can be either a single value or a list, otherwise known as a collection. They can be different types depending on languages, and they store the most recent value assigned. Here's an example of a variable in block code and in the text form for APCSP. Data abstraction. First data abstraction we're going to learn is a list. A list is an ordered sequence of elements, and each element is an individual value in the list. So for example, advanced placement in CSP, all of these are separate elements. Index is where an element starts in a list. Now here's where the College Board gets a little goofy. They start with 1 instead of 0. So normally in programming, the first item is 0 index. In CSP, it's index 1, okay? Remember that. And then strings are sequences of characters. Why are lists data abstractions? It's because they group a lot of data together and make it easier to organize and manage individual pieces of data. Next, some mathematical expressions. This is a difficult topic for calculus BC students. Just kidding. Algorithms are a set of instructions that accomplishes a specific task, and they can be constructed with a combination of sequencing, selection, or iteration, or whatever the programming guru decides. Sequencing is a process in which each action runs in the order it was written, and selections is a process in which actions are run based on if certain conditions are true or false. So for example, you have if statements. If this is true, then we run this. If this is false, then we don't run this. Iteration is a process when you repeat certain actions. For example, there can be iterations in loops. Expression is any value, operator or variable, or even a procedure that returns a value, and it produces a single value. So here's some operators. Addition, so it uses this symbol that has a vertical line and a horizontal line. It's called a plus. Subtraction uses a horizontal line. Multiplication uses a star symbol. You can remember M stands for snowflake. Division uses a slash. If you're having trouble remembering this, remember that I looks like the slash. Modulus uses the mod. This one is a tricky one to remember because obviously it says mod. What can it be? So for this one, unlike the other ones that are difficult, let's discuss modulus. A mod B basically means what's the remainder when we divide A by B. So 18 mod 3 will be 0, but 18 mod 5 will be 3. If we have a lower number here and a higher number here, so for example 3 and 5, is going to be the lower number. So it's going to be A, the first number. Okay, understand? Let's proceed. Strings. So for strings, we already learned that they're sequences of characters. String concatenation is a process when you join two strings together. So for example, you combine a string For example, too late, and then the second string, say, and then the third string, sorry. A substring is simply a part of the string. So for example, it can be I love apples, and love can be a substring of that sentence, of that string. Next is Boolean expressions. Booleans are either true or false. And here are some expressions, or rather operators, you have to know. A equals B checks if two of them are true. A doesn't equal B checks if they're not equal. Then we have the alligators that check whether they're equal or greater than, less than or equal to, greater than or less than. I think these are what you learned back 10 years ago. So should have it fresh in your mind. Next, logical operators. So not basically makes the opposite of the value. If you had true, none of that would be false. If you had false, none of that would be true. The tricky part comes with the and or operators. False and false makes false. False and true makes false. True and false make false. And true make true. So the only case where you have a true result with an AND operation is when both of the conditions are true. For an OR operator, you have true in all cases except when both of them are false. So it's kind of the opposite between the two. Next are conditionals. Remember when we talked about selection? Well, this is what a conditional statement is. And specifically, if statements. Here's how they might look on the exam. For example, if this is true, then we run this. Otherwise, we do this. We can also have nested conditionals. For example, one conditional inside the other. So in order to return this value, this must be true, and this must be true as well. Next are iterations. Remember, iterations are when you repeat a piece of code. And they can either run for a certain amount of times. They'll specify repeat 10 times. Or until a condition is met. For example, repeat until age equals 20. And then you increment the age over here. 3.9 is about algorithms. And here are some that the College Board wants you to know to succeed on the AP test. You have to determine the maximum or minimum value of two or more numbers. You have to compute the sum or average of two or more numbers. Identify if something is not evenly divisible by another integer. You can use the mod for that. And determining a robot's path through a maze. Yeah, a couple of questions are going to be about some robot that moves, and there's a certain amount of functions, and you have to see where the robot goes. If it's turn left, turn right, you'll get it. 3.10 is about lists. There's a lot of stuff about lists. Let's go over. To access an element of a list, you use this kind of square. To assign a variable to a value from a list, you use the normal variable syntax plus that element syntax. To assign a value to an element of the list, so basically do the opposite, you do the opposite. Or if you have another element of the list that you want to assign to a different element of the list, you do this. To insert something to a given index, use this structure. So what kind of list, what index, and then what do you want to insert. Appending means adding to the end. So list, what do you want to append? Removing basically removes an element from a specific index. Specify the list and then the element. And then to find the length of the list, you use the length function. You may be asking, why do I have to know so much? Don't I get a reference sheet on the exam? Well, you do, but if you have all of these down and have some practice with them, it's way easier and way faster to complete the test. The whole process takes less time. you're less stressed. You're not moving through one page and then clicking the reference button. No hassle like that. You already know it in your brain, and you can safely move to the next question without bothering about the reference sheet. Some list vocab that you have to know is traverse. It means to loop over values in a list. And linear search. It means you move through values in a list until you find a desired value. So this is an example of traversing. For each item in a list, you do something. And you have this item accessible as a variable. Now let's discuss something called binary search. In this type of search, you continuously split the list in half until you find the desired value. So let's do a quick demonstration. First, we split the list in half. Notice that we have an even amount of elements. We just choose the one on the left. Boom, we compare it to our desired element, and oh wow, they're equal. So you found it. Another more difficult example. Here we have, again, an even amount of elements. So we go to the one on the left. So we have 2 in the center, we go to the one on the left. It's 21. Is 27 greater than 21? Yes. And that means we cross out all of these numbers. You may ask, how can we cross them out? Well, because we know that they must be alphabetical or numerical. They must be in order. That's a condition for binary search. So now we look at this side. Find the middle of it. It's going to be 34. And is 34 less than 27? No, it's greater. So we cross out everything here. Now we have 27. Is 27 equal to 27? Well, yeah. So we found it. Now we have to find 10. Split the list in half. We get 11. 11 is greater than 10. So we split this. Now, is 10 greater than 5? Yes. So we cross out 5. But we have nothing here. So we do not actually find 10. So notice how I was doing these crossing out. These are the steps you're taking. So if I ask you a question, how many steps does this binary search take? And then you draw this out and see how many steps it takes. Next are procedures. Not the ones in the hospitals, the ones in CSP. A procedure is a named piece of code that can have parameters and return some kind of code, also called methods and or functions. Parameters are the values that the program expects. Arguments are the values that you pass into it. So arguments are not the same thing as parameters. Here's an example of how it might look in College Board code. Procedures interrupt the flow of the code, and the code in the procedures has to finish before the program continues. How do they show values? Well, they use the display statement, which prints the value of an expression. So that will be like print in Python, and return, that returns the value of an expression. These returns that the function does can be assigned to a variable. So for example, if a function returns something, if we see it returns an expression, that basically means this whole function is sort of acting like a variable. So we can assign it to something like result. And the result will be equal to expression. And to accept input from a user, we just use input. That's simple. How do we develop procedures? There's something called procedural abstraction, also another definition you have to know. And it allows us to use a function without worrying about the details of something inside of it. For example, we can use the function move forward. It's an abstraction. We don't really know what's behind it. We just use the words move forward. And this basically allows us to reuse, simplify, and build upon existing pieces of code. We don't have to write the same thing over and over again. And also it makes the code modular, meaning it's separated in different parts and not just in one giant program or sequence of steps. Important topic is also called libraries. Software library is a toolbox of code that has already been written by someone else which you can use yourself. This simplifies building programs because you spend less time building complex tasks. An example of a library is downloading YouTube videos or making games. There are such libraries like PyGames or another libraries that can be used to download YouTube videos. APIs are application program interfaces, and they show you how procedures in the library behave. For example, you have to call this, you have to do this. And for this reason, it requires documentation. 3.15 Random values. Generating random values can be done through this syntax or through the block syntax. And each value has an equal chance of happening. For example, generating a value between 1 and 10. Next are simulations. Simulations are abstractions of real-life scenarios. The goal of them is to allow us to see how certain things could happen in real life, and they do require simplification, meaning that they don't capture every single possible scenario. As a result, this could create bias in our programs. They're great for many types of real-life events, including costly ones or dangerous ones, because they can allow us to see how they might happen without actually doing them. And random generators, demonstrated previously, they can simulate variability in these simulations. Next is efficiency. But before we discuss efficiency, we have to talk about problems. Problem is a general description of a task. It can or cannot be solved by an algorithm. An instance of a problem is a specific case of a problem. For example, sorting is a problem, but sorting the words open, source, and education is an instance of a problem. Just some vocabulary to know. There's different types of problems. Decisions, where you have to answer a yes or no question. For example here. Optimization, where you have to find the best solution. For example, what's the shortest path between Austin and Dallas? So one is answering a question that has two options. The other one is finding a best scenario. Efficiency. Efficiency is how well an algorithm uses time and space. So the less time it uses, the less space it uses, the more efficient it is. It can be determined by number of times a statement executes. And different algorithms for the same problem can have different efficiencies. Some algorithms are reasonable and some are unreasonable. The ones that are reasonable, and you're going to have to know this for the exam, are the ones with polynomial efficiency. For example, constant, linear, square, or cube. The ones that are unreasonable are factorial, as you can see here, and exponentials, because the number of step grows really fast with the increasing in input size. So for the other ones, with constant, it does not increase at all. Logarithmic increases a bit with more inputs, but for exponential, increases dramatically with more inputs. So just remember, these ones are unreasonable, these ones are reasonable. In some cases, you have to use approximate approaches. For example, some algorithms can be solved in a reasonable amount of time. As a result, you'll need to approximate them. An important term we have to know for this topic is heuristic. It's a good enough solution to a problem. For example, it's a common example you will see. Finding the shortest route to travel between 10 cities is unreasonable. It takes way too much time. So instead you decide to travel between cities that are closest to each other, which is a heuristic. It might not be the best approach, it's an approximation, but it's a good enough approximation. Some problems are undecidable. Decidable problems can be solved with an algorithm. Undecidable are the ones that can't. For example, will the program stop running or keep running forever? That's a halting problem. Now let's do some practice on Unit 3. Here's the question. Remember 5 seconds to answer. 5, 4, 3, 2, 1. The correct answers are A and D. We are training here, so feel free to pause, review, or if you need more time to think about the question, feel free to pause earlier. Remember, on the actual AP exam, you get a little over a minute. But it's better if you can solve them in shorter amount of time, so that way you can get extra time at the end to review the harder questions. Question 2. 5, 4, 3, 2, 1. Question 3, feel free to pause it right now. The correct answer is D. Question 4. Feel free to pause. And the correct answer is B. Question 5. Feel free to pause, obviously. D. Let's talk about big idea numero cuatro. Computer systems and networks. Woohoo! First topic, internet. But before we talk about the internet, there's tons of vocabulary you have to know. A computing device is anything that runs a program. A computer system is a group of these computing devices. A computing network is an interconnected system of computing devices that send and receive data, which is an example of computing system. A path is a sequence of connected devices between sender and receiver, and routing is the process of finding a path from sender to receiver. Alright, hope you got that vocabulary down. Moving on. Next term you have to know is bandwidth. That's the maximum amount of data that can be sent at a time, and it's usually measured in bits per second. Next important topic, very important for this unit, internet. It's a computer network with interconnected devices and open protocols. What the frick is a protocol? Well, it's a set of rules and regulations. And an open protocol specifically is a protocol that's easy to access. It's accessible without specific restrictions. The internet uses dynamic routing, which means it's not made in advance. For instance, IP addresses change dynamically. For example, when you connect to different Wi-Fi networks. The scalability is a process by which a system changes in size or scale with increasing demands. And our internet is scalable. The next thing you have to know is how data is transferred in the internet. Data streams are chunks of data that are passed through packets. And packets contain both the data itself and the metadata. The data is actual information, while the metadata is routing information. For example, the receiver address, the sender address, or other information. Packets can arrive in any order or out of order. Internet protocol, also called IP, are lists of addresses that are assigned to computers. They're used for finding each other and communicating with each other. IPv4 was a standard created earlier on, and it had less addresses. IPv6 expanded to more bits, and more bits means more addresses. And it was created because IPv4 ran out of addresses, simply. Next, you have to know about two protocols, TCP and UDP. They're used for transferring data on the internet. TCP is more reliable because it checks if the packet's arrived. So it sends a packet and then goes, oh, has this packet arrived or not? If it has not, it sends it again. UDP, on the other hand, does not guarantee this delivery. It sends it and forgets about it. Because TCP checks, it's slower. UDP doesn't check, so it's faster. But in TCP, packets arrive in correct order, while in UDP, packets can arrive in an incorrect order. Out of order, essentially. So you have to know the differences between the two. Next is World Wide Web, WWW. It's a system of link pages, programs, and files. And World Wide Web uses the internet. Next is another protocol, HTTP. It's a protocol used to transfer web pages, programs, and other data through the internet. And it's called higher level protocol, or just a higher level, program because it relies on other technologies under the hood, like TCP and IP, to actually transfer the data. Fault tolerance. Fault tolerance is the ability to operate without interruptions. The internet is fault tolerant. A specific way you can achieve fault tolerance is through redundancy. It means including extra components as backups. This increases the reliability, makes it easier to scale systems, but also may have extra costs because you're buying extra infrastructure. And having two or more paths between devices is also an example of fault tolerance and redundancy. Next, we have to talk about different types of computing: parallel and distributed, and sequential as well. Sequential is when operations are done in order. So I'll give you a file and you complete the tasks in the exact order I gave it to you. Parallel is the operations are broken down and can be done simultaneously. For example, I do this process, but I also do this process at the same time. Distributed computing is when you take the processes and run them on separate devices. For example, two computers. Efficiency, also an important term, is what we learned previously. How fast and how memory effective is a certain solution. And it can be measured with time. A sequential solution, efficiency will just be the sum of time it takes for all the steps because they're running in order. The parallel solution is the sum of sequential step plus the longest parallel step. So we take the sequential solution, this, plus longest parallel step, because the other ones will be shorter and they will run in the same amount of time. So for example, if we had one that runs 80 seconds and the other one that runs 10 seconds. They run at the same time, so they start at the same time. So 10 seconds pass, this still has 70 seconds to go. So after 80 seconds, they will finish because they started at the same time. The speed up is calculated by dividing the time to run sequentially over the time to run in parallel. Parallel computing is more scalable. Parallel solutions, however, are limited by their sequential portion. So sometimes when you scale too much, it doesn't get much more efficient. And also, another advantage you have to know of systems is an advantage of distributed computing, is that it solves larger problems that could take much more time on a single computer. Practice for Unit 4. First question, and I'm going to actually go over this question because it's a little tricky for some students, as I noticed. 5, 4, 3, 2, 1. The answer is 80. But how do we arrive at this answer? Two processes are run in parallel. So that means we have at least two processors. So now what's the minimum possible time? Well, we gotta get the minimum possible maximum. Let me explain. 60 plus 30 equals 90. That means we have one step that takes 90 seconds and the other step that takes 50 seconds. They run in parallel. So we take the maximum parallel time, 90, and that's how long both of the processes will take. How long it will take to run both processes. If we take 60 and 50, then we'll have one process that runs 110 seconds and the other process that runs 30 seconds. So to run both of them, it will take 110 seconds. If we combine 30 and 50, that will be 80 seconds for one and 60 seconds for the other. And the time to run both of them is 80 seconds. So which one is the minimum? Well, it's the 80 over here. So that's why it's the answer. By adding any of them, it's not possible to get 60 seconds. So that's why the answer is 80. So when you just get the question, think of logically, add them up and see the process that we did and find the lowest amount of time. Next question. 5, 4, 3, 2, 1. Answer is A. And woohoo, hooray! Last unit, impact of computing. First, you have to talk about beneficial and harmful effects of innovations. So people create innovations, but people can view impacts of innovations differently. For example, I might like something, other person might not like something. And these innovations can have unintended consequences, which the developers do not initially predict. Another thing you have to know about positive effects is that computing has sparked more ideas and creativity in other fields, like medicine, for instance. Here are some examples of unintended consequences that the College Board wants you to know. For example, the World Wide Web was originally created for rapid and easy exchange of information within the scientific community, but now it's used by people across the whole world, not just scientists. Targeted advertising is used to help businesses, but sometimes it can be misused at different levels. And machine learning and data mining have enabled innovation in medicine, business, and science, but information in this way can also be used to discriminate against groups of individuals. So, just some examples of unintended consequences. Next topic is digital divide. It describes that different people have different access to internet based on their socioeconomic, demographic, or geographic factors. And the digital divide can be created by individuals, organizations, or governments. And digital divide reduces equity and opportunities. An example for you to know is virtual education during COVID. For example, some students who had laptops could participate in classes, while others who didn't have internet connection or laptops did not participate in classes or couldn't participate in classes because they didn't have that kind of technology required to participate. So this is an example of digital divide. Next, computing biases. Biases can occur in data or in algorithms, and the goal of programmers is to reduce the biases in their programs. And it occurs in all levels of software development. Important topic for you to know is crowdsourcing. The widespread access to information led to more solutions, and this created different methods that people collaborate. Citizen science is when research is conducted by general public in collaboration with scientists, and crowdsourcing is when information is obtained from a large number of people on the internet. This results in new modes of collaboration and new capabilities, since you have way more people working together. An example of crowdsourcing is Wikipedia, since anyone can edit the articles, and Waze, because the Waze community and people who use Waze collaborate with each other and report accidents, for example, or other occurrences on the roads. However, the internet also causes legal and ethical concerns, and digital technology as a whole. For example, property rights. The materials created on the computer is the property of the creator, and easy access to information may cause issues with property rights. As a result, measures should be taken to prevent these issues. An example of an issue is plagiarism, is when you take someone else's material without permission and present it as your own. For example, you ask Claude to make your homework, presented it to your teacher, and got a 0 because you plagiarized your work. Here are some legal ways to use someone else's work. For example, you can cite it, or you can use these methods, which are very important for the AP test. Creative Commons, basically what you have to know about it is a public license, and it allows people to use your work, build upon it. Basically, you share your work to the internet and say, y'all can use it. Open source are programs that are made freely available without restrictions, and they can be downloaded for free, modified. You can do anything with them. You can find the open source programs on GitHub, for example. Open access is online research output that's free of any restrictions, so people can use your research if it's open access. You also have to know some concerns. For example, development of software that allows access to digital media downloads and streaming, the development of algorithms that include bias, and the existence of computing devices that collect and analyze data by continuously monitoring activities, which is kind of suspicious. You also have to know what personally identifiable information is, PII. This is any information that can be linked to an individual. For example, their social security number, age, or race. We also to know that search engines and websites track their users. This can be done by using cookies, and one purpose of this is for targeted advertising, but it can also be used for more convenience, like saving our information for checkout. Another thing you have to know about information on the internet is that it's hard to remove. Once something is on the internet, it's likely not going to be removed from there, and it's very hard to delete. And this information can be used for malicious purposes, like criminal activity, stalking, and tracking social media to find personal identifiable information. Thus, you have to protect yourself on the internet. You can use this by using multi-factor authentication. Basically, authentication means protecting devices and information, and multi-factor authentication is where you have to present several pieces of information to sign in. For example, you might be asked a password when you sign into a Google account, and then you have to click yes on your phone. That's an example of multi-factor authentication. Next topic, encryption. Encryption is when you encode data to prevent unauthorized access. There's two types. Symmetric, which uses one key for both encryption and decryption, and public key encryption, that uses two keys, a public key for encryption and a private key for decryption. The difference is symmetric, one key, public key encryption, two keys. And certificate authorities, they verify ownership of such encryption keys. Next, some malicious stuff. Virus is a program that can copy itself and gain access to unauthorized information. And malware is software that is used to damage a system or take control of it. And typically, viruses and malware exploit design flaws in programs. They can be prevented by using antivirus software or controlling permissions of programs. Next, you have to know some examples of attacks. For instance, phishing attacks. It's when someone tries to trick you to providing personal identifiable information. For example, they send you a form pretending to be your bank and asking you to input your credit card number. Keylogging is when you record keystrokes on a computer, again to get personally identifiable information, like they track what you type so we can get your password, credit card numbers, and stuff like that. Rogue access point is something that intercepts network communication on public networks to, again, obtain some information. And an untrustworthy software that contains malware can also cause some attacks and also take your information. Now, practice for Unit 5. Question 1, 5 seconds. Feel free to pause, and I'll unpause in 5, 4, 3, 2, 1. Answer is C. 5, 4, 3, 2, 1. Answer is C. Remember, the digital divide is when groups are separated based on access. So, requiring to bring a calculator will separate them even further. To participate in graded quizzes, bringing a tablet to participate in graded quizzes will also divide people because some may not have a tablet. And purchasing a laptop with as much processing speed as possible is also a digital divide. It causes digital divide. It does not have a positive impact because some people may not afford such computers. Question 3. Feel free to pause. 5, 4, 3, 2, 1. The answer is D. Yo, this is it from us. Thank you so much for watching. If you liked the video and it was helpful to you, please feel free to click the like button below, subscribe to our channel, and share this video to your friends to help them study as well. And also remember to check us out at osc.codes to see our summer initiatives. Stay tuned for new videos, and good luck on your AP exams.